Okay, well, welcome back to these conversations about the DIgSILENT Power Factory. And my job in the next few minutes is to provide a general introduction about the software and how to use the software to perform, well, initially to create a network model and then to perform some power system analysis. To be honest, in this course, we are not doing something rocket science. We are doing basic stuff. Sorry about if you believe that this is so extremely basic, but it's what it is, sorry. Well, as all of you has installed the software and is already installed and working, what I will do now straight away is I will start my DIgSILENT Power Factory, okay? And and also one of the reasons that I took time, it was because I changed the screen resolution in order that all of you can see in less than 4K the screen. And I think it's very simple for all of you to see what we have in front of me, okay? Could you confirm up the chat that you are able to see Power Factory? At the chat, please. Okay, I say at the chat, but thank you. Okay, here when you start up Power Factory, first, you must be very proud and very happy that you are using the most recent version of Power Factory. I think also you are using the version that is even newer than the one that I have installed here. Here we have the version 2022, okay? Let me check here something. Okay, give me a second, and now I need to check something here. Screen, full screen, this screen. Sorry, that. Okay. Okay, let me apply the change here. Okay. Now, okay. Where is my cursor now? It's here, yeah. Yeah, okay. And now let me check what is happening here. Screen number 2, yes. All the screens. Screen number 2. Okay. Now let me close this. And okay. Okay. As I say before, you are using the version Power Factory 2022. To be honest, that is the most recent version that you can find. and I am really happy that you have the opportunity to work with this, okay? Because using the most recent version of Power Factory allows you access to the most recent development on the software, okay? And for that reason, every time that you open Power Factory and is enabled this display at the very beginning, you have the opportunity to assess and check the very different contributions that Power Factory includes in this new version, okay? And I will not go in deep details here, but one of the functionalities that I love from 2022 is that now you can define color palettes. I mean, for years, Power Factory has been boring using basic colors, but now Power Factory allows you to define your user-defined colors, and that is quite interesting, okay? Another functionality that is quite interesting, and of course you don't have this functionality because you are using the university version, but if you have a professional version, DIgSILENT Power Factory 2022 allow you to use artificial intelligence. Artificial intelligence and machine learning is something that arrived to the power systems and now has been used a lot. And now you can have a functionality inside Power Factory that allow to you create or reuse already created artificial neural networks in order to do forecasting and to do approximations, okay? That is quite interesting functionality. Also, well, next semester I'm not teaching power protections, but the new protection coordination assistant is quite useful because this year in 2022 they have included the protection coordination assistant for overcurrent, and not only for non-directional, also for directional overcurrent. That is quite interesting. Also, Power Factory allows you to use co-simulation, and that is a functionality included inside Power Factory. And there is one example that is the network from Texas that is showing how to run AMT and RMS simulation together, and it's quite useful, okay? And finally, my favorite, Power Factory includes Modelica functional mockup interface that allow to integrate Modelica models into the DIgSILENT Power Factory. That is a very interesting step forward, okay? Well, I will close this window, and the next window that appears to you is the startup window related to the samples, okay? As I say before, conversations about Power Factory is something short and simple, but if you want to learn more about the Power Factory functionalities and some other examples, I highly suggest that you go to this window, okay? This window over here presents application examples, for instance, for low voltage, for medium voltage, the Texas grid that I was talking before. This is data with more than 2,000 nodes, hydropower plant, offshore wind farms, blah 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 blah. Okay, you can use any of those examples. If you want to use those examples, what you need to do is press this button over here, and the project will be imported, and you will be able to use it. Okay, and the most exciting part about those examples is that you have videos to support your learning journey using the software. For that reason, if you press that button, you will go and watch the video related with the basic model, the introduction to the model, and blah, 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 blah. And also, there are some of those videos that they have, some of those examples that they have documentation. For instance, there are some of those videos that, some of those examples that you can read a PDF file, and if you press over there, Power Factory automatically will open a PDF file, and you will be able to read the PDF file and find more information about the simulations, results, and so on, okay? For that reason, again, this window related with Power Factory examples can be extremely useful for you, okay? I will close this window at this moment, but anytime, if you want to go back to the examples, what you need to do is go here to Files, and then go to Examples, okay? And here, Files, you can see Files, and then you can go here to Examples, okay? Well, let me start to talk about Power Factory. Power Factory is a graphic environment that allows you to develop models and to run power system analysis studies, okay? Inside Power Factory, you can identify at least several parts, okay? You can identify several parts. For instance, let me connect this here. Yeah, and try to use the... Okay, this is not working today. What the hell is happening? Okay. Okay. And okay, it's not working. Give me another second. Today has been the most crazy day. Okay. Yes, regarding your question, of course, if you look here at examples, one of the example is basically low voltage system, and it can be also used for transmission systems. You can use DIgSILENT Power Factory for low voltage, medium voltage, or even high voltage. It's a software that can be used for any voltage. Voltage level is not defining main differences. Differences in the network are created by electrical parameters, and that is one tool that Power Factory, one feature that Power Factory can move between different voltage levels and systems, okay? I hope this answered your question, Mr. Farsad. You're very welcome. I am trying to solve the problem with the pointer. We have a tool, but we cannot use the proper tool. Okay. Let me try again. Okay, now I can use this. Aha, it's almost working. Ay, what a day. Okay, coming back. When we are working with Power Factory, we have different areas that they are extremely important. we have the graphic area, we have the output window that is here below. We have here some tools and project navigation. We have here the tools. Well, to be honest, this is the toolbar. I will call this the tool bar. Okay, what does it mean? The graphic area is quite important for you, because here inside the graphic area is where you will build using graphic symbol your project. The output window is extremely important because that is the area where Power Factory is talking to you. And to be honest, the toolbar is extremely important because that is the place that you will interact with the tools, with the data, with the calculations, and everything with the software. For that reason, at least these three important parts are extremely relevant. The tools and the project navigation is something that we will be using, but again, the three main areas are the graphic area, the toolbar, and the output window. Okay, let me click here. Well, my dear students, we are almost ready to start the first project. And what I will do is I will create a very basic system for you. And this very basic system is based, let me find a paper over here. Yes. I mean, I was planning to create a system for you that will be extremely simple, okay? I found this paper, Test Distribution System, Network Parameters and Diagrams of Electrical Structure, okay? And in this paper, the authors over here, they propose several test systems, okay? And the data of those test systems are presented over here. In this class today, I will use, let me change the color because I don't like so much this color. In this class today, what I will do is I will create this test system. In this test system, as you can see, there is a bus bar number 1 that is connected to a main generator. Then there is a bus bar number 2, 3, 4, 5, 6, and 7. Okay, there are 7 bus bars over there. Extremely simple. And over here, between bus bar number 1 and 2, you can see that there are some overhead transmission lines, okay, or distribution lines. And you must recognize those symbols. They represent the bus. And this symbol over here, they represent the overhead transmission lines. However, as you can see in this paper, the authors, they give us the data. And there are loads connected at bus bar 2, 3, 4, 5, 6, and 7. Okay? Very simple. The single line diagram is extremely simple. It's basically a generator, then bus bar 2, bus bar 3, bus bar 4, bus bar 5, bus bar 6, and bus bar 7. Okay? Perfect. And in each bus bar, there is a load. Okay? Those small arrows that I am including over here, they represent loads. okay? Perfect. Now it's time to do this in Power Factory. How do we do this in Power Factory? Well, it's extremely simple. We want to create the system over there. I believe you can see that I keep on the top right hand the very basic power system, okay? Now we want to create a project. Extremely simple. You go here to File, and then you say New Project. I mean, I believe all my students, they can see that is extremely simple. You can go here to New, and then select Project. Okay, if any one of you fall behind my steps, no, don't worry, because I will share with you this video and you will be able to stop the video, move the video forward, move the video backwards, and you will be able to learn how to do it by yourself. For that reason, it's not necessarily that you follow me step by step at this moment, okay? Again, because this video will be shared with all of you. Okay, now, File, New Project. We need to define a name for this, and I will include the name Test System 1, okay? And I will press here the button that say OK. When I press that button, Power Factory is populating the database and is creating some objects for me. One of the objects that is created, you can see here the name. This is the element net, and you can see this is the green color. This is a network object, and this is the grid that is a element net. For you interested right now, what we need to do is include a name. I will say the name is grid. We need to include a nominal frequency. In this case, I will keep 60 Hertz. And you can put here your name as the owner, okay? Perfect. When you complete the data, next step, okay. And right now, Power Factory did many things for you. Power Factory at this moment create a white paper that is located in the graphic window. But that white paper, that blank area over there, is basically the area where you will create your single line diagram, okay? That is the area for the single line diagram. I don't know if you realize that Power Factory has created for you or opened for you the drawing tools. And the drawing tools over there, you can see the names and you can see a short description. If you put on the top of any of the icons the cursor, I mean, if you put the pointer here, you can see that Power Factory activate what is called a help balloon. The help balloon is something that allows you to receive a little of information related with that very specific icon. For instance, if you stop here, you will see that this is a bus bar. This one is a bus bar short. But if you stop here, you will see calculate load flow, okay? That means that right now, you are able to see a short information about each one of the features, okay? Perfect. Now, the other thing that I want to show you is those two important buttons at the top left-hand side. The one that is at the far left-hand side is the data manager. The data manager is a very powerful tool because the data manager would allow me to get access to almost every single object inside Power Factory. The data manager is like your Windows Explorer. The Windows Explorer allows you to go inside folders and find files inside the Windows environment. That is the software that you use to find your Microsoft Word documents or to find your MP4 videos, etc., etc., etc. Here, the data manager is the equivalent to the Windows Explorer. And you can get access, for instance, to the project that is highlighted in blue. Blue color means that that project is active. And as you can see, my username is FG-Longatt. FG-Longatt is my username, and inside my username, you will find the project that is active, in this case, the project that I just created, and that is the test system number 1. Perfect, I love this. Then inside the project, you will find at least four different folders. One folder for the library, one folder for the network model, one folder for the study cases, one folder that you never touch, settings. Okay? Okay, but the data manager is the most powerful tool because you can access almost everything inside Power Factory. The second most powerful tool is the icon that is located immediately to the right side of the data manager. And that button opens the Network Model Manager. The Network Model Manager, we can say that is the smallest son of the data manager, because the Network Model Manager gives you access only, and very only, the access is limited to the objects inside your project. That means that this is not so powerful as the other button. In the other button, you have access to every single object inside your project and outside your project. But with the Network Model Manager, you have access only to the objects inside your project, okay? For that reason, you will be using this Network Model Manager many times. Okay, perfect. Well, let's start to build the system. I always suggest to my students that you start to build your system, starting from the bus bars. Okay? There are different types of bus bars here. I always suggest my students that in this class, because this is something short and simple, use the bus bar that you can see over here that is called terminal, okay? I will show you again. Let me do it in slow motion, okay? You can go here, you just click. When you click the icon, automatically you can see that the cursor, the pointer, the mouse pointer, they change the shape. Because right now you will be able to insert your very specific bus bar. And then when you press click, I mean the left button in your mouse, well, you will get the terminal at this location, okay? When you finish, you need to select escape, because otherwise every time that you click the system, every time that you click the mouse, you will insert more and more bus bars, okay? Okay, let's do the following. This bus bar is horizontal, but I want this bus bar oriented in 90-degree rotation. For that reason, right button, and I will say rotate clockwise. And now I have this bus bar similar to this one, okay? And what I will do is I need 1, 2, 3, 4, 5, 6 more. What I will do is copy and paste. Copy and paste, copy and paste, paste. We have 1, 2, 3, 4, 5, 6, 7. Okay? Now we have 7. We have 7 bus bar. The next step is that I would like to change the names because the names are 1, 2, 3, 4, 5, 6, 7. I want to have the same names over here. And I will do so. But at the same time that I am doing so, I am really clever and I will follow the next step because it's not only changing the name. I need to make sure that my students understand that the test system number 1, that is a 7-bus system, all the data is presented here in table 1 and 2. But most important is that you understand that the voltage level of this transmission system, the voltage level, sorry, of this distribution system is 12.66. 12.66. That means that this system over here, the voltage should be 12.66. The voltage level, the nominal, should be 12.66, okay? What I will do now is double click at the bus bar. The name will be 1 and the voltage will be 12.66. Then I will do the same for the next bus bar, number 2. Then I will do the same for 3. And I will show you one way that you can change the voltage. Very simple, okay? This is number 6 and this is number 7, okay? What I will do is I will zoom in. Okay, this is number 7. Okay, how do I change the voltage faster? I told you about this button over here that this is the network model manager. As you can see, we have elements that they are called here terminals. And you can identify the names 1, 2, 3, 4, 5, 6, 7. And I will find the place. You can see over here that the nominal voltage should be 12.66. And what I will do is the classical copy and paste that every single student around the world, they like, the copy and paste. And right now, when I access the data using this network model manager, I was able to include all those voltages, okay? Next step, I need something that provides the electricity to this network. Because I need that, I need to come here to this area that represent sources. You can see over here, the name of that section is sources. And in these sources, I will take this one, the external grid. Okay, let me do that. What I will do is I will click here. I will click on the top of the bus bar number 1. And then I will press escape. Now we have external grid. What is external grid? External grid is a model of the remaining part of the power system. This is the object. This is the object element net. Okay, this is green. That is the reason that it's an element, and net means external grid. But I want to know more about this. Of course, you can learn more about this. Of course, you can learn more about this. And I highly suggest that you do that. How do I learn more? Well, if you want to learn more, what you need to press is F1. Because when you press F1 inside Power Factory, Power Factory automatically will open the help menu. I mean, it will open the menu for helping you to identify and to understand more the software. And in this case, the user manual is going to the technical reference for the models. And in this case, you will be able to identify the different objects that you have inside Power Factory. And here you have sources, here you have generators and load, here you have transformers, here you have branch elements, and if you keep going, power electronic device, shunts and filters, ground elements, load flow, measurement devices. I mean, the documentation of Power Factory is so extensive that you can learn about almost everything inside the software. In this case today, I am interested on the external grid. Because I want to learn more about external grid, what I need to do is press the button and open. Power Factory have what we call technical reference. This technical reference is dedicated in this very specific case today to the external grid. The name of that object is the element XNet. And as you can see over here, there are different parts of this very important technical reference. There is a section for load flow, there is a section for short circuits, there is a section for harmonics. Today we are interested on load flow. We are going to the load flow, and you can see that inside the load flow you can specify the bus type. And in this model today, I want to select that external grid as the slack bus bar. And to do so, that is extremely simple, okay? You can read the technical documentation, but I will do that in a very simple way. I will put here the name. Where is my external grid? Here is my external grid. Now I will go to load flow because I want to specify the load flow, and I will select SL because SL means the slack bus bar, okay? I will repeat. I will go here to the element. I will go here, double click the element external grid. Then I will go to load flow. And then I will go inside the slack bus bar and select slack bus bar. Perfect. Now we have installed one external grid, and this external grid is providing the energy to the system. What is the next step? The next step is I need to install the transmission lines or distribution lines. What I will do right now is I will use this object. The object is called line. The line is a branch element that must be connected between two different buses. For that reason, I will install between here and here, click here and click here again, click here and here again, click here and here again, click here and here again, and click here and here again. Perfect. But now we create the drawing for the transmission lines. Now we need to put the data. But the first data that I will put is the name. For instance, In basic data, this is the line 1, 2. This is the line 2, 3. This is the line 3, 4. This is the line 4, 5. This is the line 5, 6. And this is the line 6, 7. However, those lines require more data. Those lines, if I double click one of them, you will see that I need to include, because this is an object that is called ELM line. And remember, this object also requires the type of that line. To do so is extremely simple. However, before I include the new object, I must tell you that in this object, what we need to say is the resistance, the reactance, and the capacitive susceptance. For that reason, what I will do is I will go to the data, I will go to the PDF file, and now I can see here the resistance and the reactance. And also we have here the nominal current, okay? Between bus bar 1 and 2, this is the resistance, this is the reactance, and this is the nominal current. Well, let's go to the first transmission line. I will select here, new line type, select new project type, line type, and this is 1, 2. The voltage is 12.66, 0.5 kiloamps, and I need the resistance and the reactance. What I will do is I will go to the PDF file. And I will select here. Why cannot select 0.0922? 0.0922, and the reactance is 0.0407. 0407. Perfect. Now we need to do the same for the net, and 12.66, 0.5, and let me go here, 4930, and the other one is 2510, 0.2510. Let me do the same for the next one. New project type. .5, and the resistance is 3660, and the reactance is 1864. Then the next section, the section 45, and this is 12.66, 0.5 kiloamps, and then we have one, which one is this one? 5.6? No, 4.5. 4.5 is 3811, 3811, and the next one is 1941. Perfect. Then 56, create new line type. This is 56, 12.66, 0.5 amps, and 56 is 1872, 1872, and the other one is 6188, 6188. Perfect. Finally, line 67, new project type, line 67, 12.66, 0.5, and the data is the data is 1714 1.7114, and the next one is 1.2351. Perfect. Let me check the following. This is figure number 1, the system number 1. The system number 1 is 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, okay? And the data here is 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. Why do they include this 7, 1? Okay, let me go back to the single line diagram. What I will do is you can move these in order that you can have the better representation as you wish, okay? You can move the objects, graphical objects, inside the graphic window. And moving that is extremely simple. You just click, select, and you use the classical drop in order to move the objects, okay? Okay, right now we have all the transmission lines. Right now we have all the transmission lines. What I will do now to be sure that everything is fine is I will check the data in the network model. To check the data in the network model, you can see over here that we have all the transmission lines, but we have an issue with the names of the types. For instance, this type should be 2, 3. This type should be 3, 4. And this one should be 4, 5, 5, 6. Okay. And then I want to check the voltages. The voltages are okay. The current is okay. And then resistance and reactance, they are located over here. You can see this is for the resistance and these are for the reactance, okay? You can see over here, resistance, and reactance, okay? Perfect. Well, I think we are ready to do some tricks over here. We want to see if this is working. And the best way to see if this is working is let's run a load flow. Running a load flow inside Power Factory is extremely simple. You just need to go here to this icon. And in this icon, if you press that icon over there, this window will appear. And this window over here is extremely important because this is the command load flow. In other words, this is a command that when you press execute, this will run the load flow. Now let's try to do the following. Here there are several configurations inside the load flow command. However, we will not change any configuration at the moment because we are running the classical AC load flow. I believe all my students, they receive a lot of very good classes and lectures about load flow. For that reason, I will not spend time, but I believe them realize that everything that was explained during the load flow classes, you can find here. For instance, you can find different calculation methods. AC load flow, balance, unbalance, DC load flow, tap changers, voltage regulation. Also, you can see over here how to control the active power, some advanced options related with operational limits and so on. I highly suggest that you match your theory coming from your classes of those top level high quality lectures, and you compare that and check here all that knowledge. Okay, what I will do now is just run the load flow because I want to be sure that everything is running here. I run the load flow. Oh Jesus, what is happening here? Well, when we run the load flow, Power Factory is extremely helpful, because Power Factory show you here the results in the single line diagram. You can see over here voltages, line to line voltage in kilovolts, voltage magnitude in per unit, and phase angles in degrees. Probably you are wondering, okay, everything is zero. I mean, the active and reactive power is zero here, there, and somewhere else. And the voltage is 12.7 in every single bus bar. What is happening? Well, the explanation is extremely simple. What is happening here is that we don't have any load. And if there is no load in this system, of course, all the voltages are equal to the rate voltage of the external grid, and the currents are zero, and the active and reactive power is zero. For that reason, the next step is installing the loads at bus bar 2, 3, 4, 5, blah, blah, blah. Okay? What I will do is the following. I will install those loads in the system, starting from bus number 2. Where is bus number 2? Here, yes? 2, 3, 4, 5, 6, 7. The load is located here. You can identify the location because this is a general load. And I will install the load. You click here and then load 1, 2, 3, 4, 5, 6. Okay? What I will do now is I am changing the size of the bus bars, and I will move here a bit low. Okay? This will be the load number 2. This will be load number 3. This will be load number 4. Number 5. Number 6. And number 7. Okay? Now I need to complete the flows, the active and reactive power. To do so, double click and then go here to load flow. At the load flow folder, you can see active and reactive power. And what I will do is I will go here. How much is the active power? The active power is for load number 2, 100 kilowatts, 60 kVAR. Okay? Okay, we need to do something here. We need to change the units. To change the units is extremely simple. You can see over here active and reactive. If you double click here, I want to use for the load flow kilo. For that reason, right now, oops, what's happened? Load flow calculations, yeah. Should be load flow, yeah. Oh, it's here, sorry. Here in megawatts, here in kilowatts. Now it's kilowatts here. And the numbers are, this load is, okay, let me check here. This is the load number 2. The load number 2 is 160 kVAR. Load number 3 is 90 kilowatts with 40 kVAR. Then we have the load number 4. Load number 4 is 90 with 40 kVAR. Then we have the load number 5. The load number 5 is 120 kilowatts with 80 kVAR. Then we have the load number 6. The load number 6 is 60 with 30 kVAR. And finally, we have the load number 7, and that is 60 kilowatts with 20 kVAR. And it's time to check the data. You can go here to the Network Model Manager, and you can see at the Power Flow tab, you can see here the active and reactive power. What I'm telling you is, if you use the Network Model Manager and you go to General Loads, you will identify all your loads, and here you can see P and Q. Perfect. Now it's time for a load flow, and now I will run the load flow, and voila, we have load flow here. But probably the load flow, as you can see over here, the load flow is 0.5 megawatts, because megawatts, the units still being extremely high. What I will do is the following. I will change the units at the output variable from mega to kilo, and I will run the load flow. And right now you can see this is 520, that is 520 kilowatts, and the reactive power is 270, okay? What I will do here right now is I will show you the way to include more information. For instance, we can do here text boxes. What I did was basically the context menu. If you use the right button of your mouse and you select here text boxes, you can create a summary box. And in the summary box, what is interesting is that you can get from there, for instance, the total active power losses, the total power coming from the external grid, and so on. What I suggest is the following. What I suggest is that you have time to check everything here, and all those numbers are coming from the equations that my colleagues teach you about load flow. And if you have time, and also if you have the interest, I highly suggest that you use the numbers that we already provide, use the equations that somebody else give you, and from there you can calculate all those results, okay? Now, probably you are wondering, okay, is this all for today? And I will tell you, yes, this is the class for today. What I will do is the following. Right now, we will finish the class, the conversations about the DIgSILENT Power Factory. In a few minutes, I will export this project and I will share with all of you. You can have a copy of them and also try and use it. But I highly suggest that you try to create the network from scratch. Later tonight, I will prepare the video, I will check the video, and I will try to upload tonight to YouTube. However, I'm not sure if the video will be ready in YouTube today, but hopefully tomorrow morning we will have it for all of you, okay? At this moment, I will open the door for some question and answer. Any question from my students at the moment, please?